Whenever we look up at the night sky, it's almost impossible not to feel a little overwhelmed by just how vast the universe really is. Our minds immediately flood with questions, right? How was all this created? Just how far out does it reach? But I think the most intriguing question of all is, what terrifying secrets is this cosmos still hiding from us out there in the dark? Well, today in this explainer, we're taking a deep dive into the absolute darkest corners of space to unpack the universe's most intimidating phenomenon.
So if you're wondering what the darkest place in the universe actually is, it's the black hole. Literally, the ultimate point of no return. We're talking about a region of space where the gravitational pull is so unfathomably strong that it just swallows everything in its path. Even light, the fastest thing in the entire universe, goes in, but it never comes out. And because of this complete absence of light, they're totally invisible, which definitely earns them their ominous name. Inside one of these cosmic beasts, everything we understand about reality just shatters. The laws of physics literally stop working, and even Sir Isaac Newton's fundamental rules of gravity completely collapse. So here's a quick roadmap for our cosmic journey today. First, we'll look at how black holes form. Then, number 2, the 4 types of black holes, which is really our core focus today. Third, we'll explore what happens if we fall in. And finally, how do we actually see the invisible?
Okay, let's jump right into Section 1. How do black holes actually form?
To really wrap our heads around this, we have to rewind our timeline a bit, going back over a century to 1916. A scientist by the name of Karl Schwarzschild used Albert Einstein's new theory of general relativity to propose something that honestly sounded totally wild at the time. He said, if you take any mass, let's just say the entire Earth, and you compress it down into a small enough sphere, the density gets so extreme that it actually collapses into a black hole. Now, back then, people practically mocked this as pure science fiction. But fast forward to 1971, and that mocked theory became hard reality. Scientists found the very first black hole, sitting about 6,000 light-years away from us. So in just over 50 years, we went from this crazy mathematical theory to actual, undeniable discovery.
Right, moving on to Section 2, the 4 types of cosmic holes. And this brings us to what we really want to focus on today, breaking down and comparing the 4 unique types of black holes side by side. The scale differences between them are just absolutely massive. We're talking about a range from something as tiny as a single atom, all the way up to something billions of times larger than our own sun. Let's look at exactly what each of these means.
First up, we have miniature black holes. And this is a terrifying paradox. But a hole the size of a single atom can somehow pack the mass of a massive mountain and just effortlessly consume everything around it. Scientists actually think these were formed right after the Big Bang. Next, we have stellar black holes. These are born from just pure cosmic violence. When a really massive star, we're talking at least 25 times larger than our sun, finally dies, it explodes in a massive supernova, shining billions of times brighter than the sun itself, and leaves behind a stellar black hole. Then, moving to the third type, we have intermediate black holes, which is exactly what it sounds like. It happens when multiple stellar black holes crash into each other and just merge together into one giant void.
But the crucial takeaway about the fourth type, the supermassive black hole, is the sheer, incomprehensible scale of the thing. These monsters sit right at the center of galaxies and were actually born alongside them. To give you a real sense of the size we're talking about here, just look at that number. The supermassive black hole at the very center of our own Milky Way galaxy, which is called Sagittarius A star, is over 4 million times larger than our sun. 4 million! All right, on to Section 3, the scary part. What if we fall in?
So, before you even realize you're doomed, you would cross something called the event horizon. Think of this as the absolute boundary. It's sometimes described as a blind well. Essentially, it's the ultimate trapdoor in space. You can't see through it, and the moment anything, whether that's matter, energy, or even light, crosses that invisible line, coming back is completely impossible.
And if you did cross that line, well, the physics gets incredibly weird, incredibly fast. Because the gravity is just so intensely concentrated, the pull on your feet would be drastically stronger than the pull on your head. And this causes a real documented scientific process called spaghettification, which, yes, literally means your body gets stretched out into a long cosmic noodle. But it actually gets crazier because of something called the time dilation effect. Imagine if you could somehow pull out your phone and video call a friend on Earth while you were falling in. You would see them moving in super fast forward, watching entire years of their life flash by in seconds. But to them, they would see you moving incredibly slowly, basically frozen in time at the edge of the hole.
Now, hearing all of this, a lot of people naturally start to worry about our own sun, so let's debunk a massive myth right here. Our sun is never going to turn into a black hole and eat the solar system. It simply does not have the mass required for that extreme compression we were talking about earlier. In about 5 billion years, when our sun finally dies, it's just going to swell up into a red giant and then quietly fade into a cool white dwarf star. And honestly, even if it magically became a black hole right now with the exact same mass, it wouldn't suck us in. Earth would just keep orbiting it exactly the way it does now, though obviously we would absolutely freeze without the sunlight.
But what if Earth went completely rogue and fell into an existing giant black hole? Well, it's a pretty grim hypothetical. Believe it or not, at first we'd actually glide in surprisingly smoothly. We probably wouldn't even notice right away. But very quickly, Earth's own gravitational pull would just be completely overwhelmed by the black hole. The sheer tidal forces would rip our entire planet into tiny, microscopic fragments.
Which brings us to Section 4. How do we see the invisible?
Because this is a fascinating scientific paradox, right? If no light escapes and these objects are literally 100% pitch black, how on earth do we even know they're out there? Well, we look for the visual fingerprint they leave behind, which is known as the accretion disk. So while the event horizon itself is completely invisible, the space immediately surrounding it is absolute chaos. As the black hole shreds apart nearby stars and planets, all that leftover dust and gas swirls around the edge at unbelievable speeds. And the intense friction from all that movement heats the matter up, creating this massive, violently glowing ring. So we can't see the hole itself, but we can very clearly see this glowing graveyard of shredded stars basically circling the drain.
And how are we capturing images of this glowing ring? By relying on some truly incredible technological marvels. NASA uses highly advanced satellites, and most notably right now, the James Webb Space Telescope. Now, this telescope doesn't just sit in our backyard. They positioned it a staggering 1 million miles away from Earth. That powerful vantage point lets scientists peer deep into other galaxies, safely observing the absolute most violent and destructive phenomena in the universe, all without putting humanity anywhere near the danger zone.
So, we've seen just how terrifying these 4 types of cosmic voids can be today, from the little atom-sized killers to the supermassive galaxy eaters. But all of this leaves us with one final, super provocative question. As powerful as black holes are, is there something even more dangerous lurking out there? Interestingly, theoretical physics points to the existence of something called a white hole, a bizarre anomaly that, instead of violently sucking matter in, violently ejects it out. Now, we haven't actually seen one yet, but remember, black holes were once just a mocked mathematical theory too. So what else is hiding in the dark out there, just waiting to be discovered? Keep looking up and stay curious.